Welcome to The Explainer. Today, we're diving into a tool that's quietly changing the game for data analysis. It solves a problem that so many of us have felt, but maybe couldn't quite put a name to. So let's start with this. Have you ever been in this situation? You've got this awesome state-of-the-art laptop, multiple cores, tons of RAM, but the second you try to analyze a dataset that's even moderately big, everything just grinds to a halt. Your Jupyter notebook crashes, you're staring at a loading bar, and your whole workflow is just dead in the water. So what is going on?
Well, it turns out this problem actually has a name. It's a frustrating barrier that tons of people in the data world hit, and a lot of times they don't even realize it's a specific solvable issue. This is that awkward, super painful middle ground. Your data is maybe a few gigabytes, way too big for Excel, and it's definitely too big to comfortably fit into memory with the tools you normally use. But it also feels like complete overkill to spin up a complex, expensive cloud service like Snowflake or BigQuery, right? You're just stuck. It's a total paradox if you think about it. On one hand, data is just everywhere. Log files, sensor data, user events, it all adds up fast. On the other hand, our laptops are ridiculously powerful now. Multi-core CPUs, super fast SSDs. The real problem is that our go-to software tools were designed in a completely different era. They simply can't take advantage of all that modern hardware, and that creates this massive, frustrating gap between what our machines could do and what they actually do. Okay, so let's get into the nitty-gritty. Why specifically do our standard tools fail us so badly when we hit this ceiling? It really all comes down to their fundamental design. And let's be honest, we all love Pandas. It is the absolute workhorse of data science in Python, but its whole philosophy is built around being in memory. When you read a file, it wants to load the entire thing into your computer's RAM. Plus, most of its operations are single-threaded, which means it's only using one of your laptop's powerful CPU cores. So the moment your data gets bigger than your available RAM, you don't just see a little slowdown. No, you hit a performance cliff, and your entire workflow just comes to a screeching halt. So you might think, okay, I'll just use a database. But to get why that's often the wrong move, you have to understand this really key difference. You've got OLTP systems like SQLite, which are built for quick, tiny updates. Think of changing one user's address in a huge customer list. They store data in rows, which is perfect for that job. But analytical queries, OLAP, are a completely different beast. They need to scan millions of rows, but usually only in a few specific columns, like calculating total sales across the entire country. Using an OLTP tool for an OLAP job is like trying to hammer a nail with a screwdriver. I mean, you might eventually get it in, but it's going to be ugly and wildly inefficient. And this is what leaves developers stuck in this frustrating trilemma. Pandas is memory-bound. SQL is just the wrong tool for the job, architecturally. And a traditional data warehouse, well, it comes with its own tax. The headache of setting it up, the slowdown from network latency, and that tedious process of extracting, transforming, and loading your data, ETL, before you can even ask your first question. Every single choice forces a major, painful compromise. This huge, frustrating gap in our toolkit, well, it's precisely the void that a new wave of technology was basically born to fill. This is where the story takes a turn. A whole new category of tool has emerged, one that was designed from the ground up to solve the exact problem of the local data ceiling. And honestly, that nickname is just perfect. Like SQLite, it's in process. What does that mean? It means it's not some separate server you have to install and manage. No, it's just a library that runs right inside your application or your notebook. It completely eliminates that data warehouse tax. No installation, no configuration, no network. But, and this is the key, unlike SQLite, it is a pure OLAP engine, built from day one for blazing fast analytical queries. But okay, here is the real game changer, the thing that completely shatters that slow, painful ETL cycle we talked about. You don't have to load your data first. You can just write a SQL query that runs directly on your Parquet file or your CSV file, or even on a Pandas data frame that's already sitting in memory. It can even reach into another database like Postgres and run a super fast analytical query on its tables. This is a complete revolution for your workflow speed. Okay, so you're probably wondering, how on earth does DuckDB pull this off? How can it give you data warehouse level performance on just your laptop? Well, it's not magic. It's just some brilliant engineering that stands on 3 core pillars. And the cool thing is how these 3 ideas work together in this beautiful, virtuous cycle. First, columnar storage means you have to read way less data from your disk.
Then, vectorized execution processes that data in really efficient batches. And finally, Morsel-Driven Parallelism makes sure all of your CPU cores are working on the problem at the same time. So let's break that down. All right, pillar number 1, columnar storage. Instead of storing data in rows like a traditional book, DuckDB stores it vertically by column. And to get this, the library analogy is just perfect. Just think about that for a second. If your query only needs, say, 2 columns out of 50, a row-based system has to read all 50 columns from the disk just to throw 48 of them away. It's incredibly wasteful. A columnar system, on the other hand, only reads the 2 columns it actually needs. This simple change leads to a massive reduction in the amount of data being moved around, which is a huge, huge performance win.
All right, so we're reading way less data. That's a huge win. The next pillar is all about how we process that data more efficiently once we have it in the CPU.
You see, traditional databases are kind of like a craftsman processing data one row at a time. There's a lot of overhead. Vectorized execution is completely different. It's like a modern assembly line, processing data in big batches or vectors of 1,000 or more values at once. This is just way more efficient for modern CPUs. But that brings us to the final piece of the puzzle: parallelism. Remember how we said old tools only use one of your CPU cores? Well, DuckDB is built to use all of them. It breaks the data up into small chunks, or morsels, and lets every single available core on your machine grab a chunk and get to work simultaneously. It's like turning that one-person artisan shop into a fully staffed factory floor, finally unlocking the real power of your hardware.
So when you put all of these pillars together, what you get isn't just a little speed boost. No, it's enabling a massive simplification in how we even think about doing data analysis.
And while are people noticing? The adoption has been absolutely explosive. Over 7.5 million downloads a month on Python's package manager alone. That number tells you just how widespread and painful that local data ceiling really was. Developers were starving for this solution.
And these aren't just vanity metrics. The real-world wins are staggering. We're not talking about saving a few seconds here. We're talking about transformative change. An 8-hour process becoming an 8-minute process? That completely changes what a business is capable of. It unlocks new questions and new ways of working that just weren't even possible before.
What this all boils down to is that DuckDB is leading this powerful counter-movement. For years, the answer to any data problem was always go bigger, add more complexity, add another distributed system. DuckDB proves that for a massive number of situations, you can just not do that. You can replace that entire complex pipeline with a simple script on one powerful machine. It's about right-sizing the solution to the problem.
And this, for me, is where it gets really exciting. We're moving from a world where data analysis was this big, clunky, centralized destination to a world where it's a tiny, powerful capability you can embed anywhere. Think about real-time analytics on an IoT device at the edge, or super interactive data exploration happening right in a web browser without ever hitting a server. By making high-performance analytics so accessible, DuckDB hasn't just given us a faster tool. It has opened up an entirely new frontier. So the final question is, with this power now available to everyone everywhere, what are we going to build next?